All right, Bismillahirrahmanirrahim. In today's another class of mechanics, we're going to be solving another paper that is May June 2021, variant 41, variant 1. That's 41. All right, now, Miss Aisha, uh, a winch operates by means of a force applied by rope. A winch is used to pull a load of mass, 50 kilogram, up a line of greatest slope of a plane inclined at 60 degrees to the horizon. All right, a winch is used to pull a mass of 50 kilogram. Let me draw mass. All right. This is 50 kilograms, so it's going to be force of mg, Aisha. All right. And this is 60 degrees. All right, 60 degrees. The winch pulls the load of the winch pulls the load. Okay. There's a rope. All right. There's a rope, and the winch pulls the load a distance of 5 meters up the plane at constant speed. $5. All right, and at constant speed, so the speed is constant. There's a constant resistance to motion of 100 newtons. So, Aisha, if it is moving upwards, so if it is moving up the plane, the force of resistance, so frictional force is going to be acting down the plane. All right, Miss Aisha and Miss Amna and Mr. Mustafa. And then we have, all right, then we have what? Then we have basically the tension. All right, tension. All right. And this is a force. This is a force that is this is a force that is also exerted by the winch, basically. All right. Now, I'm going to be using, because they are saying to calculate the work done by the winch. Now, it's your choice, Miss Aisha Lagari. It's your choice. You may use Newton's second law. Use Newton's second law to calculate the work done. That is, of course, you will be calculating this force by the winch. That is also the tension in the rope. And then you're going to be multiplying it with 5. You're going to get the work done by the winch. Or you may use the work energy theorem. That is, you calculate the work done by each of these forces. All right, equals to change in kinetic energy, which is 0 because the speed is not changing. All right, the speed is not changing, so the change in kinetic energy is going to be 0. So it's your choice. Now, let me show it to you how we're going to do this using the work energy theorem. That will be the work done by this force by the winch is T times 5. All right, Aisha. And now, when you're calculating the net work done, you're going to be associating negative and plus and minus signs with the work done by each of the forces. So if you see that, okay, this is the force exerted by the winch, and this is the direction of displacement. So if the direction of force and the direction of displacement are same, then that work done is taken to be as positive. But if you look at this force of friction, so this force of friction acts along this displacement. So the direction of this force of friction and the direction of displacement, they are opposite to each other. So the work done by friction is going to be taken as negative. All right, and that is 100. 100 times 5. And then we have the work done by the gravity, because all right, we have the work done by the component of gravity. This is, we're going to resolve this force of gravity into two components. This is going to be 60 as well. There's going to be mg cos of 60, and this is going to be the opposite component, which is mg sine of 60. So if you look at carefully, Miss Aisha, so you have this component of force of gravity acting along the plane, acting along the plane, and that's what we're going to be using over here as well, because we have the displacement, along the plane, and we have like this another force that is acting along the plane. So there would be work done by this component, as well. And if you look at the direction of this component is down the plane, while the displacement is up the plane. So we're going to be taking this work done as negative as well. So minus mg, which is 500. Mg is 50 times 10 times sine of 60. All right, sine of 60. And sorry, times the displacement, which is 5, and equal to 0, because there's no change in kinetic energy, because the speed is constant and there's no other work done as well. So there's going to be 5t minus 500 minus it's going to be 2500 sine 60 go to 0. And okay, I'll be taking instead of writing down t into 5, you may just even write down work done by tension, because that's what you are supposed to find out. Work done by winch. You're not supposed to find out the force exerted by the winch. You're supposed to find out the work done by the winch. So in this equation, if you are using the work energy theorem, you just simply write down the work done by the tension, basically, which is the work done by the winch. So WT is going to be equal to 500 plus 2500 sine 60. Amna, do you have the calculator? Amna, do you have the calculator? Aisha, is it clear to you till now over here? Is it clear?
Yes, sir.
Okay.
Yes.
Amna? Oh.
Yes, sir, I'm calculating.
Yeah, just calculate this. Let me know the value.
2665.
2600 and
65.
1600 approximately joules. All right, that's what you are getting, the answer.
The answer is to three significant figures. 2670.
Okay. All right, let's move on. Okay, and then also, if you would have used this, Amna and Aisha and Mustafa, you would have used this formula, the Newton's second law. In fact, both are Newton's second law. This one is expressed in terms of force and acceleration, while this term is expressed in terms of work done and kinetic energy. But if you would have used this one, you would have then found the value of T first, and then you would have multiplied it with 5 to get the work done by the winch. All right. Now, two particles A and B, Amna, have masses m kilogram and 0.1, Aisha, and m is greater. M is greater than 0.1. Okay. If m is greater than 0.1 and the system is released, so m is going to be moving downwards while b is going to be moving upwards. All right, like this. The particles are attached to the ends of a light extensible string. The string passes over a fixed smooth pulley and the particles hang vertically below it. Both particles are at height of 0.9 meters above horizontal ground. The system is released from rest, and while both particles are in motion, the tension in the string is 1.5 Newton. So the tension with respect to B is going to be directed away from B, 1.5 Newton, and the tension with respect to A is going to be directed away from A. It's going to be 1.5 Newton as well. particles are attached to the ends of a line in extensible string. Okay. Both particles are at a height of, okay. Particle P does not reach pulley. Okay. Particle P does not reach pulley. Find M. Now, now this is an example of connected particles. And for connected particles, Aisha, I always explain to the students, while we are covering up, while we are like learning about these kind of particles, I always explain them. I always ask them to consider each of these particles separately. All right. So I have this as Mg, sorry. This is Mg. All right. Now I'm going to be looking at A first. I'm going to be applying Newton's second law. No. Yeah. I'm going to be applying Newton's second law. And so I'm going to be taking as upward positive and downward negative. So I have T as positive 1.5. And plus I'm going to have minus Mg, which is a minus M, 10M, minus 10M. Equals to any other force at on A? No, we don't have any other force. It's going to be minus MA. Why minus MA? Because the acceleration of A is directed downwards and we have taken downwards as negative, so minus MA. So I have then 1.5. I have then 10M minus MA equals to 1.5. All right. Yeah. Yep. I can have then substitution for 10M equals to MA minus 1.5. MA plus 1.5. Yeah. No. Let me factor out M. Sorry. Let me factor out M. It's going to be 10 minus A equals to 1.5. So M is going to be equal to 1.5 divided by 10 minus A. Or you may factor out A, it's your choice. All right. But because we are supposed to, yeah, never mind. So 10 minus 1.5 divided by 10 minus A. All right. Okay. Then I have for B. For B, I have 1.5 again positive plus I have minus 10 into 10 into 1. 10 into 0.1 is basically 1. So minus 1. All right, that's the force of gravity. Minus 1 equals to MA. So the acceleration of the B is upwards is going to be taken as positive. So it's going to be 0.1 A. So you're going to have then 1.5 minus 1. A is going to be what? A is going to be 1.5 minus 1 is 0.5 divided by 0.1. 5 meter per second square. You're going to substitute over here. Calculate M, and it's going to be 1.5 divided by 10 minus 5. 1.5 divided by 5 is what? Is 1.5 divided by 5 is 0.3 kilograms. Is it clear to both all of you? Ms. Aisha, Ms. Amna, and Mr. Mustafa.
Yes, sir.
Yes, sir.
Okay, 0.3. And find the speed at which A reaches the ground. So we have calculated the acceleration. We know that the acceleration is going to remain constant throughout until A reaches the ground. So I can use any of the equations of motion. I have the displacement 0.9. I have the initial velocity as 0. So V square equals to U square plus 2AS. So U is 0. V square is something I mean to find out. To acceleration of A is directed downwards. So minus 5 into minus 0.9. V square is going to be 10 into 0.9 is 9, and v is going to be equal to 3 meter per second. Is it clear to both of you or not? All of you?
Yes, sir.
Yes, sir.
All right, that's great. Then, Aisha, three particles, P, Q, and R, of masses 0.1, 0.2, 0.5, are at rest in a straight line on a smooth horizontal plane. Particle P is projected towards Q. All right, three particles. Okay, particle P is projected towards Q. P is projected towards Q. After P and Q collide, P rebounds with a speed of, okay, Q is at rest basically. Okay, and P rebounds and Q is going to move towards right, of course. So, okay, let's move on. Let's do the working. So, I'm going to using the law of conservation of momentum. So, I have M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. And I'm going to be taking right as positive, left as negative. So M of P is going to be 0.1 times 5, and it's both towards right. Speed of P is towards right, taken as positive. Then we have M2, which is 0.2 times 0, because the Q is initially is at rest. Then I have 0.1 times minus 1, because P is moving on the left, towards left after collision. And M2 is 0.2 times V2. And I'm taking V2 as positive because I'm assuming that Q is going to be moving towards right. If the value of V2 comes out to be negative, then then the result would be that the Q would be moving towards left. If the value of V2 comes out to be positive, then my assumption would be correct, that the Q moves towards right. So it'll be 0.5 minus 0.1 plus 0.2 V2. 0.2 V2 equals to 0.6. And so V2 is going to be equal to 3 meter per second. Is it clear or not? Coming out to be positive, that Q moves towards right after collision. Miss Aisha, Miss Amna, so Mustafa, is it clear?
Yes, sir.
Yes, sir.
Okay, that's great. That's great. Q now collides with R. Immediately after the collision with Q, R begins. Okay, now Q and R, they are colliding. Q and R are they colliding. R then moves towards right. Okay. Let us again apply Newton, law of conservation of momentum, which is M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. And Q 0.1, no 0.2. 0.2 times 3 plus R is at rest, so it's going to be 0.5 times 0. Now, as for Q, now what should I to have the greatest possible value of V? The Q must be moving. sorry, the Q must be moving towards left after collision. Why? Let me show it to you. So if Q would be moving towards left, Q now collides with R immediately after the collision with Q. R begins to move with speed V. And the speed of Q immediately after the collision with V. Okay. There is no subsequent collision between P and Q. Find the greatest value of V. Okay. So Amna. Okay, we have the for R I have 0.5 times V. All right. Now to have the greatest value of V, to have the greatest value of P, to have the greatest value of V, R must Q must become stationary after colliding with R. After colliding with R, Q must become stationary. Because after colliding with R, if Q is going to be moving, so the speed V is going to get decreased. All right. Is it clear or not, Ms. Amna?
Yes, sir.
Q is going to be then 0.2 times 0. To have the maximum speed, to have for R to attain maximum speed, so as soon as Q is going to collide with R, it must become stationary. All right. And this would be an example of an inelastic collision. It would be an example of elastic collision. Because in inelastic collision, we have some loss of kinetic energy. But for in an elastic collision, we have the kinetic energy conserved as well. So yeah. But anyways, for for R to attain maximum speed, Q as soon as the Q collides with R, it must become stationary, and then R must move forward. Then they would have the greatest. The R would attain greatest possible value of V. All right, and so it's going to be 0.6 equals to 0.5 V, and it's going to be equal to 1.2 meter per second. If Q hits R, and after hitting R, it moves along with R towards right, then we would then Q will have some velocity. So you will have some value over here. Then you're just gonna move it towards left and then subtract it from 0.6. So we would get decreased. So to have for R to attain maximum value, Q should come to rest immediately after colliding with R, so that R can attain maximum value of V. Is it clear or not, Ms. Amna Rizwan? Ms. Aisha?
Yes, sir.
Sir.
Yes. Okay. Two cyclists, Isabella and Maria, are having a race. Oh, wow. They both travel along a straight road with constant acceleration. They both travel along a straight road with constant acceleration starting from rest at point A. Okay. Constant acceleration. That means you can use any of the straight line and constant acceleration. You can use any of the equations of motion. From rest, initial velocity is 0. Isabella accelerates for 5 seconds at a constant rate of a meter per second square. Given that a equals to 1.1, for she then travels at a constant speed. She has reached for 10 seconds. Before decelerating to rest at a constant rate of over a period of 5 seconds. Maria accelerates at a constant rate, again reaching a speed of 5 meters per second in a distance of 27.5 meters. She then maintains the speed for this, okay, before decelerating to rest over a period of 5 seconds. Given that a equals to 1.1, find which cyclist travels further. So I'm going to be using, I've been given the value of a, I've been given time. Okay. Like, oh, like, all right. Now, this time is like 5, and this is like 15, and then this is 20 again. This is 0. All right. And this for Isabella. This is V meter per second. This is time per second. All right. And okay, I need to calculate this maximum. So I'm going to be using V equals to U plus 80. So V is going to be equal to U is 0. So 1.1 times 5 is going to be how much? Or you may just calculate the gradient. Calculate the gradient as well. So 1.1 into 5 is 5.5 meter per second. This is 5.5. Now, Amna, can you just calculate for me the distance by calculating the area of the region under the graph? It's going to be half times 5.5 times 5 plus half time, sorry, plus 10 into 5.5. This is a rectangular region, so 10 into 5.5. Then we have half times 5.5 into 5. Amna, 5.5 into 5 is
The answer is 27.5 multiplied by 1 upon 2.
plus 55.
13.75.
No. Yeah, but these are the two same. These two are same, not just add them. Adding them up is going to become 27 and a half, I reckon.
Okay.
Plus 55. So it's going to be 82.5.
82.5.
Yeah, 82.5 meters. And what about Maria? Okay, I'm just going to copy this graph. Let me just copy this. Copy. Okay. Let me redraw it over here. Aisha, is that clear to you till now?
Yes, sir.
Oh, it's not getting copied. Anyways, for Maria, we have the highest speed is like V5. All right, so the distance is going to be then half times 5 into, no, 27.5. Yeah, it's like 27.5. She then maintains the speed for a period of 10 seconds. Again, 10 into 5. Before decelerating to rest at a constant rate over a period of 5 seconds. So what is going to be again half times 5 times 5. So how much is going to be then? 25 over 2 is 12 and a half. And it's going to be 40 and plus 50, 90 meters. So Maria travels greater distance. Maria travels further. Is it clear, Miss Aisha?
Yes, sir.
Find the value of A for which the two cyclists travel the same distance. Oh, wow. So you may keep the distances. Okay. So if the value is unknown for A, if the value of A is unknown, so V is going to be equal to 5A, 5.5A. No, 5A basically. Yeah. So going to be half times 5 into 5A. All right. So in place of 5.5, 5.5, 5.5, I'm going to be placing 5A. The initial velocity of Isabella. Sorry, the final velocity of Isabella. All right. Half into 5 into 5A. All right. And then I have, okay, just let me put up over here. And then I have 10 into 5A. Then I have half into 5 into 5A. I'm going to keep that equal to 9. I'm going to keep that equal to 90. No. Travel the same distance. So there's no unknown there's no A in Maria's case. So I'm gonna keep that equal to 90 degrees. Because that is what the distance the Maria has traveled now. We don't have any the A is not varying in case of the acceleration is not varying in case of Maria. All right. There's just one value of A in case of Maria. So there won't be any change in distance for Maria. But yeah, if you going to change the value of A in case of Isabella, her distance is going to get changed. So I'm gonna keep the I've kept this distance traveled by Isabella equivalent to the distance traveled by Maria equivalent to 90. So it's going to be 12 and a half A plus 12 and a half A plus 50A. So it's going to be 25, 75 A equals to 90. And A is going to be equal to 6 over 5. Is it clear or not?
Yes, sir.
Amna, are you verifying the answers as well?
Yes, sir.
Okay. Ms. Aisha, is it clear or not? Any question you have?
For me, it's correct.
Okay. Let's move quickly on question 5. Okay, that seems to be easy. Find the value of T at point B. Aisha, what you're going to do? Find the value of t at point B. Find the value at point B. What is point B? Okay, it comes to instantaneously at rest. So I'm gonna keep first when I find out V, which is the integral of a dt equals to integral of 6t to the power of half minus 2t. So for V, I'm going to have expression as equivalent to 6t 3 over 2 divided by 3 over 2 minus t square plus c. And we know that it starts from rest. So starts from rest means that t equals to 0, the velocity is 0. So c is going to be equal to 0. So I'm going to have V as equivalent to 12 over 3, 4 t to the power of 3 over 2 minus t square. And now if I'm going to keep that equal to 0, 43 over 2 minus t square equal to 0. I'm going to get what? Let me factor out t to the power of 3 over 2. 4 minus t to the power of half equal to 0. T to the power of 3 over 2 equal to 0. T to the power of half equals to 4. Am I doing it correct? Yes. So t is going to be equal to 0. And I'm going to take the square on both sides. It's going to be 16. So t equals to 16 seconds. Because at t equals to 0, it is at the particle is at point A. So at t equals to 16 seconds, the particle must be at point B. Is it clear or not, Miss Aisha, Mr. Mustafa, and Miss Amna, Mr. Umar, and everyone?
Yes,
Clear?
sir.
Yes, sir.
Yes, sir.
Okay, good enough. Final distance travel from A to the point at which the acceleration of the particle is again 0. Okay, we have how many questions? 6, and then we have 7. Okay. Find the distance traveled from point A to the point at which the acceleration of the particle is again 0. So let us first find out that when the acceleration is coming out to be 0, at what times the acceleration is 0. So let's find out. So we're just going to keep acceleration as equal to 0. 60 to the power of half minus 2t equals to 0. So now we're going to have t to the power of half and 3 minus t to the power of half equals to 0. So I have t to the power of 0 and I have t to the power of half as equal to 3. I'm going to have t equals to 0 and 9 seconds. All right. 0 and 9. So we have at point A, the acceleration is 0. And again, when the acceleration is 0, the t is equal to 9 seconds. All right. And if you look at, okay, so I need to calculate the distance traveled from A. Have I done it correctly? Yeah. So from point A, if you have over here point A, so it comes instantaneously to rest at a point B. So at point B over here. All right. And then yeah, I'm supposed to find out the distance traveled from A to the point at which the acceleration of the particle. Okay. To calculate the distance, I'll be taking the integral of V. And what is V? We have 4t to the power of 3 over 2 minus t square dt. All right. And we have s equals to 4t to the power of 5 over 2 divided by 5 over 2 minus t cube over 3 plus c. So now at t equals to 0, the displacement is 0 because the displacement is measured from A. And at A, the time, and when the particle is at A, the time is taken to be 0. So it's going to be 0 to the power of 5 over 2 divided by 5 over 2 minus 0 to the power of 3 over 3 plus c. S coming out to be 0. Sorry, c coming out to be 0. So you have s equal to 8 over 5. 8 over 5 to the power of 5 over 2 minus t to the power of. Now I can calculate, it. So the time at which the acceleration becomes again 0 is t equals to 9 seconds. I'm going to substitute t equals to 9. So Amna, what is going to be 3 to the power of 5 is 243 times 8. 243 times 8 is what? 243 times 8 divided by 5. It's 388.8. 9 into 9 into 9. Amna, what are you getting the final answer? 243 into 8.
So I'm calculating. It's 9 cube, right? 9 cube upon 3.
Yeah, 388.8.
145.8.
145.8. So 146 meters. Is it clear or not?
Yes, sir.
Yes, sir.
Okay. Question 6. Hurry up. We have like 22 minutes. 3 coplanar forces. Now this is quite easy. Given that the component of the resultant force in the x direction is 0. So let's first find out the expression for the resultant force in the x direction. So this is going to be tan sine alpha and cos alpha. And what is going to be this? Tan 25 cos 60. 25 sine 60. And what is going to be this? Aisha? 20 sine 30 and 20 cos 30. All right. Now let's for in the x direction I have towards right. Towards right, of course, is going to be taken as negative. It's going to be 25 cos 60 plus 10 cos alpha minus 20 cos 30. Twenty-five cos 60, 10 cos alpha, 25 cos 60, 10 cos alpha minus 20 cos 30 equal to 0. So all right, bachcho. All right. So I have 25 cos. I'm not getting you just calculate for me 12.5. How much is going to be this? Let me just 10 cos alpha is going to be equal to 20 cos 30. Yes. What is value you are getting? Amna?
Yes, sir. I'm calculating. 0.482.
Alpha.
61.2.
51.2 degrees.
61, sir.
61.2 degrees.
Yes.
All right, that's great. And find the magnitude of the resultant force. Okay, so you're gonna have only the resultant in the y direction. So let's tan sine alpha. Okay, tan sine 61 degrees plus 20 sine 30 degrees. 20 sine 30 degrees. Tan sine 61, they are both positive, acting upwards. And then minus 20 sine 60. So we are gonna have Fy. Yes. Amna, what are you getting then? Fy is gonna be equal to the resultant force because we don't have any resultant in the x direction. Whatever the resultant you are getting in the y direction, that's going to be your overall resultant force as well.
Uh, 1.43. One point four three.
So again, 1.43. Is the answer correct?
No. The answer is 2.89.
What did you miss? It's 10. The answer for alpha is correct?
Yes, it's 61.2.
10,
20
61.
sine 30 minus 25 sine 60.
No, it's not 25 sine 60. Yeah, it's 25 sine 60. I've written
In
it
the
20
marking
sine
scheme is 25 sine 60. Yes. Answer is 2.89. Yes. 2.89 is the answer, sir.
Okay, okay. I've written this correctly, Fy.
Yes, this is it. The alpha is 61.2. So it's 10 sine 61.2.
Okay. Otherwise, and else is correct. 20 sine 30 plus and minus 25 sine 60.
Yes, sir.
Okay, what's the final answer you're getting?
2.89.
2.89 newtons. Is it clear, Miss Aisha?
Yes, sir.
Okay. Okay, then we have given that instead alpha is 45. Find the magnitude and direction of the resultant of three forces. Okay, good enough. So we have in the direction of f of x, fx, I'm going to have what? 25 cos 60 plus 10 cos 45 minus. So I'm just going to be replacing, replacing over here. I'm just rewriting this expression for f of x. I'm not going to be keep fx as equal to 0 because now you are going to have resultant in the x direction. And I'm going to replace alpha with 45 minus 20 cos 30. So I'm not going to just tell me
2.251.
2.25 Newton. Okay. And then for Fy, we have 10 sine 45. And then we have 20 sine 30. Then we have minus 25 sine 60. Yes. Amna?
Negative 4.58.
Negative 4.58.
58.
Now to calculate the resultant Fr basically, we're going to be taking the square of fx plus square of Fy. All right, Amna, can you do it for me? 2.25 square plus minus 4.58 square. What are you getting?
5.10.
5.10 Newton. Okay, that's great. And to calculate the magnitude, I have so 2.25 is towards right,
Yes.
minus 4.58. Yeah, like this. So we have this resultant. 2.25 and 4.58. I need to calculate this theta. And this is actually south of east. All right. Because if you are over here, Aisha, if you are over here, you are moving towards south. All right. This angle represents what? You are over here on the horizontal ground. This angle is measured from the horizontal axis, and you are moving towards the south, this vertical axis towards south, because this is north, this is south. So like from the horizontal axis, you're from this is east. So from east, you're moving towards south. You're moving towards south of east. So what is the angle that you are going to get? Theta is equal to 10 into 4.58. 4.58 divided by 2.25. What are you getting?
64.9.
64.9 degrees. 64.9 degrees south of east. All right. Is it clear or not? Miss Aisha?
Yes.
Miss Amna? Clear? Okay. Mr.
Yes.
Mustafa? Aisha, is it clear, beta? One last question. A slide in the playground descends at a constant angle of 30 degrees.
Direction is below positive x-axis, and the answer is coming 63.8.
All
Minus
right.
4.57. Resultant is 5.1. Okay, yes, it is 63.8. Yes. Okay, so answer is correct. And the
Okay.
direction is below positive x-axis.
Yeah, fine. A slide in a playground descends at a constant angle of 30 degrees for 2.5 meters. It is then it then has a horizontal section in the same vertical plane as a sloping section. A child of mass 35 kilograms. So you have the force of gravity acting on it. mg. Modeled as a particle, starts from rest. U is equal to 0. In the same vertical plane as a sloping section. Okay. And slides straight down the sloping section. She then continues along the horizontal section. She then continues along the horizontal section until she comes to rest. Okay, she comes to rest, let's suppose over here. There's no instantaneous change in speed when the child goes from sloping section to the horizontal section. Okay. So like, the speed remains the same along the both section. The child experiences a resistance force. The child experiences a resistance force along the horizontal section of the slide. The work done against the resistance force on the horizontal section, okay, 2.5, 250 joules per meter. It is given that the sloping section of the slide is smooth. Now this surface is smooth, this is rough. And the work done against friction on this surface is 250 joules per meter. Not the total work done, because we don't know how far the ball travels, how far the particle travels along the horizontal section. So we've been given that per meter work done against friction is 250 joules. It is find the speed of the child when she reaches the bottom of the sloping section. You need to find out this one. V1 and this is V2. So how are we gonna V1? How to calculate V1? I'm gonna be using that work energy theorem. And so what are the forces acting on the, all right? So let me resolve this. We have this 35 mg cos 30 degrees, mg sine 30 degrees. All right. So I have this only component of the force of gravity acting along the plane, no other component. All right, because, and also no force of friction because this surface is smooth. So the only work done on the particle while it is moving along the plane is the work done by the component of gravity, which is and also the displacement is downwards. The component is the direction of component is downwards, so it's going to be positive mg sine of 30 degrees equals to, is there any other force? No. Half m v square minus u square. Sorry, just a second. Forgot to add up the distance, which is 2.5 meters. Equals to half m v square minus u square. U square is 0. M and M is going to get cancelled. So G times 2 is 20 sine 30, which is 10 times 2.5 is 25. So V square is going to be 25. And so V is going to be equal to 5 meters per second. Is it clear or not? Miss Aisha? Samna?
Sir, ma'am.
Aisha, is it clear? Aisha?
Pass.
She's not in the class? Okay. And then find the distance that the child travels along the horizontal section of the slide before she comes to rest. Okay. Okay, so I have again net work done, change in kinetic energy. So along the horizontal section, you don't have any component of gravity doing work on the particle along the horizontal section. While the particle is moving along the horizontal section, you don't have any component of gravity, force of gravity doing work on the particle. All right, and what else? What only the only that Amna, the work done against friction, and yeah, that work done against friction, that's going to be taken as negative because the friction is going to be in the opposite direction to the displacement while the particle is going to be moving along the horizontal plane. So negative work done by friction is the only work done on the particle while it's moving on the horizontal section, equals to change in kinetic energy, which is half into 35 into 0 square because it's come to rest finally, and minus 5 square. So Amna, it's going to be minus work done against friction. Amna, what are you getting? 25 into 35.
Baba.
25
25
into
into
35
35.
is 875.
Divided by 2 is 437.5.
437.
So yeah, we just cancel the negative sign. So it's going to be 437.5 joules. Now that's a total work done. That's a total work done. 437.5 joules. All right. So total work done against friction. And we know that the work done per meter along 1 meter. All right. So we have like 250 joules of work that is done along 1 meter of the horizontal section. So along how many meters you're gonna have this work done? Total work done. Amna?
Yes, sir.
Just divide 437.5 with 250 to get X.
1.75.
1.75. Is it clear or not?
Yes.
Oh, that's great. Now one last part and then we're going to end. It is given that instead the sloping section of the slide is rough and the child comes to rest on the slide 1.05 meter after she reaches the horizontal section. Find the coefficient of friction between the child and the sloping section of the slide. Okay. So we're gonna have then force of friction as well. And it's going to be acting up the plane. All right, Amna? Just a second. Let my Apple Pencil get charged a little bit. Amna? Amna? So we have the force of friction acting upwards now. As the particle is moving along the sloping section, the force of friction is going to be acting upwards. And so let me just do one thing. Okay, so we're gonna have then Amna, this is 60 degrees, I reckon. 30 degrees. So this is mg cos 30 degrees, mg sine 30 degrees. This is mg. This is the force of friction. All right, Amna, force of friction. And then Amna, what we have then? So I'm gonna be again. Amna. So we
Yes,
have.
sir.
Okay, let's calculate the final speed. net work done equals to change in kinetic energy. So, okay, the work done by friction. What is the total? All right, and also we're gonna have R as well. Amna, R. And so I can let me write down the equation. So F, and it's going to be negative because it's the displacement and the force of friction are opposite in direction, plus the work done by the component of gravity mg sine of 30 degrees into 2.5. Amna equals to half m v square minus u square. U is going to be equal to 0. All right, Amna. So I can replace now. Let me apply Newton's second law. Let me apply Newton's second law along the in the direction perpendicular to the plane, and I'm going to take positive and negative like this. So I'm going to have R as positive plus minus the component of gravity that is perpendicular to the plane is mg cos 30 equals to 0 because there's no acceleration of the particle perpendicular to the plane. So R is going to be equal to what is that? What is the mass? Mass is 35. So R is going to be equal to 35 times 10 is 350 cos 30. Amna, quickly.
303.1.
What is?
303.1.
303 Newton. All right. And Amna, then we have mu R minus 303 mu. Minus mu times 303 times 2.5. All right, Amna, and then we have 35, 350 sine 30 into 2.5 equals to half into 35 into v square. Amna, what you are getting? What is the value? What is the value you are getting for this? 303 into 2.5. Quickly.
757.5.
Okay, 757.5 mu. And what is for what is for this? 175 into 2.5. Come on, hurry up.
437.5.
437.5. 437.5 meters. Sorry. And then what's for this? 35 over 2 is 17.5. 17.5 v square. All right, Amna.
Yes, sir.
Now, for the horizontal section, Amna, we have again net work done equals to change in kinetic energy. So we have along the so we have work done against friction would be 250 because along the horizontal section you have the work done against friction is 250 joules per meter. So 250 times 1.05. That's going to be the work done against friction negative equals to half into 35 Amna into v square minus half into it would be 0 square minus v square. All right, Amna, 250 times 1.05. Come on, hurry up. Need to go for namaz.
62.5.
250 into 1.05.
Answer is 262.5.
262.5. Okay. Equals to 17.5 v square. All right. Minus and minus is going to get cancelled. And so I can replace now 262.5. I can replace 17.5 v square with minus 757.5 mu plus 437.5. All right, Miss Amna. So now can you just tell me 757.5 mu equals to 437.5 minus 262.5? How much is going to be? The value
The
of this
coefficient of friction is coming 0.231.
coefficient of friction is coming 0.231. That is the correct answer. Is that the correct answer?
Yes, I'm just checking.
Okay.
Yes,
So
sir.
that's it.
Correct answer.
We're done with the
Yes, sir.
paper. We'll meet in tomorrow's class with another paper, inshallah.
Allah Hafiz.
Take care. Allah Hafiz.